Welcome back to AI Practical Applications. My name is Jack Dowling. I'm the CEO of Odom Technology Group. And so the first topic we'll talk through in AI in the utility industry is preventative maintenance. AI has been used for preventative maintenance for quite some time, and it's being used more and more in the utility industry. And the kind of things that it's being used for, what people are doing is they're outfitting their equipment with sensors, and they record data from those sensors over a period of time. And over a period of time, the AI can begin to see patterns of failure. And those sensors are typically picking up readings that indicate that failure is imminent. So for instance, electrical transformers, they're measuring insulation and temperature. For gas turbines, they're measuring vibration and temperature. For power generators, they're measuring temperature and vibrations. For water pumps, they're measuring flow rates and vibrations. And for HVAC systems, they're measuring temperature, humidity, and vibration. The challenge is knowing when to provide maintenance to machines that maximize uptime without wasting money. The traditional approach has been the most experienced employees determine when to service based on previous experience, which meant typically maintenance is being done earlier than it needs to be. New approach is to use the sensors and AI to determine when certain conditions that represent potential failure are present. And the benefits are reduced downtime due to breakdowns and reduced cost and improved profitability due to just-in-time maintenance. So next, we're going to talk about grid optimization. It's about optimizing delivery of electricity by predicting demand and adjusting supply. The challenge is to effectively manage the power grid so that electricity is available where it's needed at a reasonable cost. The traditional approach has been a combination of systems and people that monitor usage and alter the grid based on observation. The new approach is to use AI to monitor the power flows and curtail the load to match generation in real time or near real time, which previous systems couldn't do. The benefits are increased efficiency, lowered costs, and more reliable service. So next we'll talk about energy management. So energy management is about analyzing data from smart meters and other sources to identify opportunities for efficiency improvement. Energy forecasting is analyzing usage and weather data for forecast demand. Load balancing is analyzing data from smart meters, weather forecasts, and to determine optimal energy for each location. Demand response is analyzing customer usage to tailor incentives for reducing usage. And energy efficiency is analyzing data, meter data to predict usage. The challenge is effectively managing the power grid so electricity is where it's needed at a reasonable cost. The humans read the meters, humans study the data has been the traditional approach. The new approach is using the sensors to read meters in real time and using AI to analyze the data. What companies are getting out of it is increased efficiency and lowered costs. So next we'll talk about cybersecurity. And this is all about detecting and responding to cyber threats in real time and preventing attacks on critical infrastructure. So with data collection and prepping from the networks and system logs that are used in machine learning algorithms, they're using the log information. And the feature extraction is identifying relevant features from the data. The machine learning piece is detecting patterns and anomalies, and real-time analysis is monitoring the data and detecting threats. Alert generation and response automation is alerting security personnel or automatically responding to suspicious traffic, compromised devices, or shutting down affected services. The challenge is finding needle in a haystack. I mean, there's a lot of traffic on a network. And And when these attacks start to occur, without the help of software, it's difficult for people to identify an attack before the attack is becoming successful. And so the traditional approach was humans physically detected threats and took action. The new approach is to use AI to analyze the data, detect the threats, and take appropriate action. The benefits are increased efficiency and speed to mitigation and far superior results. So now we'll talk about autonomous vehicles. I know that you guys are seeing this, what's happening in the news around autonomous vehicles. And there have been accidents associated with them, but at some point, they're going to work out the kinks on this, and autonomous vehicles are going to become mainstream. I mean, they're going to become primary. And there's a number of reasons for it. Increased safety is number one. Reduced accidents, efficient operations, monitoring and managing fleets more effectively for route optimization, real-time traffic and weather. Improved asset management. You tie in sensors and collect data on the performance of utility assets such as power lines, transformers, and substations. And reduce cost to get increased efficiency via 24/7 operation. The enhanced customer service is basically quicker response to service requests, outages, and emergencies. So the challenges historically have been maximizing asset utilization and efficiency. The traditional approach is service professionals drove the vehicles. The new approach is going to be for AI to pick the route, drive the vehicle, and integrate with smart grids and IoT. The benefits are operations and maintenance improvements, safety improvements, data collection, remote monitoring, and responsiveness. So natural language processing, you guys are hearing a lot about large language models like ChatGPT. These things are already being utilized in business very effectively. And so they're being used to improve customer service and optimize energy usage and increase operational efficiency. So in the customer service arena, you've got chatbots and virtual assistants, which are getting more and more human-like. I mean, it's downright spooky how good some of them are. And you're going to continue to see that. And eventually, I think you'll see customer service handled by virtual assistants is going to be superior to humans. And the reason is because once you train them, they're 100% trained. And they answer the questions right every time. And it's just, that's a function that's better performed by a machine if you can make the machine sophisticated enough to perform the task as well as a human. Eventually it'll perform the task better than a human. So energy usage analysis is monitoring social media and customer service interactions to figure out if there's a problem. A lot of times those things will start to show up on social media before customer service really has an ability to tick and tie the calls they're getting to a specific problem. Social media can help with that. Demand forecasting is providing customers personalized feedback on their energy usage, primarily by looking at their meter usage. Asset management is analyzing data from maintenance records and other sources. Utilities can identify patterns in equipment failure and schedule timely maintenance. And then compliance reporting is analyzing regulatory documents. Natural language processing can identify relevant information and generate reports very quickly. So the challenges have been providing world-class customer support, maximizing the asset and manpower utilization, response, and providing world-class responsiveness and compliance, regulatory compliance. The traditional approach has been human effort, and that's expensive, and a lot of times not nearly as effective as when machines do it. In fact, once machines are tuned up to do it, they'll do it better. A new approach is for natural language processing to be used in call centers and all automation related to documents and communication. So the benefits are customer satisfaction, demand forecasting, improved demand forecasting, knock dead compliance. I mean, complete compliance. And then improved asset and manpower usage. So the next topic is generative AI. Now, I've got a lot of bullet points on here because it's being used in a lot of ways, and this has all started to happen very quickly. So it's being used to enhance efficiency, improve operations, and address challenges. Some of these things we've already covered, but we didn't talk specifically about generative AI being utilized. So we're going to talk about how generative AI is being utilized. So for preventive maintenance, it's being used to analyze historical data, sensor readings, equipment performance, and predict when utility infrastructure such as power lines, transformers, turbines, or other devices might require maintenance. This predictive capability helps utilities schedule maintenance proactively, which reduces downtime and prevents unexpected failures. Grid optimization. Generative AI can assist in optimizing the power grid by analyzing complex data sets related to energy consumption. And they can do this very fast in a way that humans can't do. And so, they analyze complex data sets related to energy consumption, weather patterns, and grid performance. And the models can generate insights to improve load balancing, reduce energy losses, and enhance overall grid reliability. Energy demand forecasting. Generative AI algorithms are analyzing historical energy consumption patterns, taking into account factors like weather conditions, economic indicators, to forecast future energy demand. Accurate demand forecasting helps utilities optimize energy generation, distribution, and pricing strategies. So fault detection and diagnostics is AI. These generative AI models can be trained to detect anomalies in utility systems. For instance, they can analyze sensor data to analyze irregularities in power flow, voltage levels, or equipment behavior, and that early detection allows for a quicker response and improved system reliability. Energy trading and pricing. Generative AI can be used to analyze market trends, historical pricing data, external factors that can affect energy markets, and utilities use that information to optimize energy trading strategies to set competitive pricing and to make informed decisions about when to buy or sell energy. Grid planning and design. AI can assist in designing and planning the expansion or modification of utility infrastructure. By analyzing the geographical and environmental data, along with current grid performance, these models can generate optimal plans for new power lines, substations, and renewable energy installations. Renewable energy integration. Generative AI can help utilities integrate renewable energy sources into the grid more efficiently. By analyzing weather patterns, solar and wind data, as well as grid conditions, the models can optimize the integration of renewable energy, ensuring stable and reliable power supply. So customer engagement and demand response. It can be used to analyze customer behavior and preferences. By understanding understanding customer demand patterns, utilities can implement demand response programs that encourage consumers to shift their energy usage during peak and off-peak hours, and that improves the grid efficiency. I think you'll see that energy companies will become a lot more interactive with customers in the future using these systems. And natural disaster preparedness. AI can assist utilities in predicting and preparing for natural disasters. By analyzing historical data and weather patterns, the models can provide insights into, how big and bad a storm is going to potentially be, and they help utilities develop strategies to mitigate the impact of hurricanes, floods, or wildfires. Cybersecurity, we talked about that, and these generative AI models can contribute to enhancing cybersecurity measures by identifying patterns indicative of potential cybersecurity threats. These models can also help utilities detect and respond to attacks on their critical infrastructure. So future usage in future AI usage in utilities, um, renewable energy integration. By analyzing the data from solar panels, wind turbines, and weather predictions, AI can predict energy production and adjust distribution accordingly. Energy store management is, batteries are getting better and better all the time. A lot of it's been driven by, um, the electric vehicles. A lot of the battery development has, but it's sort of taken a life of its own. And utilities are highly interested in being able to store energy so that they can utilize it in peak time periods, and then just store it when you're not at peak. And by analyzing the data from the batteries and other storage systems, AI can predict energy demand and adjust the distribution accordingly. And generative AI, we just talked about that. You get ChatGPT, Bard, and others. You've got systems that companies are building internally specific to the purposes that we just talked about. And so, I think you're going to see that usage broaden considerably as we go forward in time, because people are creative and AI is powerful, and it's going to be used for more and more purposes. So that's the end of this session. I try to keep these sessions where it's just me talking kind of short, because it's a lot more interesting to listen to the interviews. But I think these are critical to help people understand AI and how it's being used in the industry. I intend to do these across every single industry out there today. I'm going to do how AI is being used in that industry across every industry where AI is being used heavily. And so my next session will be on how AI is being used for computer vision, and how DevOps is being used in those applications. And this is a great session. You're going to really love that one. So please make sure you attend that one. Thank you. And we'll see you in the next session.